In this video, we will analyze the ABCA4 variant, a 2626C-T nonsense variant for eligibility towards ASO therapies. We first begin with a variant check. Using a tool such as Mutalyzer, as suggested by our guidelines, we can check if the variant is correct by inputting the information in the tab indicated here in HGVS notation and by clicking Normalize. We can see here that this notation is correct, and that the corresponding p-dot notation is also correct. At this step, we can also check if an ASO is already available. We will walk you through a strategy on how to go about this search, but it is up to the preference of the evaluator what tools they can use. This is just one way of approaching this. One thing I like to do for nonsense or frameshift variants, in addition to searching for the specific variant, is also search for ASOs designed for skipping of the exon this variant is found in. We can do this by inputting the gene and c-dot notation into the search bar of the UCSC genome browser, a resource shared in our guidelines. This highlights the location of the nucleotide. Here in the blue, our transcript is indicated. If we mouse over the transcript over here, we could see the exon indicated. So we can see here that this is exon 17 out of 50. With that being said, we can conduct a literature search for whether there has been an ASO developed for this variant or exon. First, I will check for the specific variant, and here I have created a search in the query box that includes our variant, different names of ASOs, the different notations of the same variant. If we search this up, no results appear. Next, I will check if an ASO was created for skipping of exon 17. Here in the query box, I can put the name of the gene as well as the different names for ASOs and the specific exon, exon 17. When we click search, we get one return, which is a paper by Kaltak et al. In 2023. The paper is titled Stargardt Disease Associated In-Frame ABCA4 Exon 17 Skipping Resulting in Significant ABCA4 Function. In the results of the abstract, we see that the proband with the canonical splice site variant has late onset of this disease, and that skipping of exon 17 may not have deleterious effects. Therefore, ASOs can be designed for the skipping of exon 17 to reduce pathogenicity of severe variants harbored in exon 17. Since there is an ASO designed, according to our guidelines, this would be considered eligible. So I searched for an exon skipping ASO at step 0. Additionally, one can go through this pipeline where they check inheritance pattern and variant mechanism as well, and since this is a nonsense variant, we can jump to step 4. At step 4 in the guidelines, we are directed to which guidelines we can use. In this example, the inheritance pattern is autosomal recessive and the pathomechanism is loss of function, so we can assess for exon skipping. For more details, please see the CTSF video example.